Hello, I'm Professor Blackman, and welcome to Solving Inequalities. So in this, we're going to look at different types of inequalities. Here are the different symbols that you see. We have less than, greater than, less than or equal to, greater than or equal to, and sometimes we have the does not equals. We also need to be able to solve them and write them out using interval notation, set notation, or be able to graph them. Depending on your instructor or the textbook you're using, one or multiple of them may be used. So with interval notation, uh, when we have less than or greater than, we use parentheses. With less than or equal to or greater than or equal to, we use brackets. So here, as you see with if it's less than, here with this x is between a and b, we use the parentheses. X is between a and b where both are included, we use brackets. And then you have combinations of is it just a included or just b included, where you can see the brackets or parentheses being used. Also with interval notation, we use parentheses um, and infinity symbols. Infinity will never have a bracket because you can't reach infinity. And so here you see a getting larger and larger and larger, going to positive infinity. If a is included, bracket. If a is not included, parenthesis. And here you see it going towards negative infinity. Uh, and so here we have our set notation. This little line right here means such that. So this is read as x such that a is less than x less than b. And then on a graph, you have parentheses or brackets that correspond to the interval notation or the less than or equal to's. Some textbooks use open circles. So you might see it like this, with here this being A and this being B. And some textbooks, if they use open circles, then they also use closed circles to show included or not included. So the textbook that I use uses parentheses and brackets, which correlate perfectly with interval notation. So that's the one that I also teach. But I have seen textbooks that use the open circles, so I want to share that here. Our second goal is we want to be able to solve inequalities. I have here the addition properties. So if a is less than b and you add c to both sides, it stays a plus c less than b. If a is greater than b, you add c to both sides, then the inequality stays the same. What changes is when you see a negative. When you multiply or divide by a negative number, it flips. So here, if we add or subtract or multiply a positive number, the inequality here and here stays the same. But if you notice here with negative numbers, it changes and we have to flip that inequality sign. So this is a very important note that you have to know when solving inequalities, because when you're solving equations, left side equals right side equals left side. But with inequalities, one of those sides is larger than the other side. So you have to pay special attention when multiplying or dividing by a negative number. So I want to make sure that is included into your notes. All right, let's go ahead and start looking at some examples. All right, so just like solving, what we are going to do is we are going to get x by itself. So I'm going to subtract 2 from both sides. And now I have x is greater than -1. So this is our solution that's here. If we want to write that in interval notation, starting at -1, going towards infinity. This is a parenthesis because infinity is always a parenthesis, and this is a parenthesis because, as you see, it doesn't include -1. Okay, for set notation, that would look like x such that x is greater than -1, and then put the curly brackets around it. And then for our graph, start by drawing a number line. Here's 0, here's 1, here's -1. And I would say starting at -1 and going that way is what my graph would look like. All right, let's go ahead and do another one. I add 4 to both sides, add 4. And so now I have x is less than or equal to 6. And so less than or equal to 6. So I'm going to start at -infinity and go to 6. -infinity always gets a parenthesis, and this 6 is included, so it gets a bracket. All right. For set notation, it would be x such that x is less than or equal to 6, and put those curly brackets around it. On a graph, I draw my number line. Say here's 0, 1, 2, 3, 4, 5, 6 would be over here. And so I would put a bracket right there, and then I would shade in everything to the left of 6. Right? Here, it's already solved for x, and so that would be our solution already, but we're starting at -3 and going to 1. This is included. This is not, so it gets a parenthesis. So we'd say x such that -3 less than or equal to x less than 1, curly bracket. And then on a graph, here's 0, here's 1, 1, 2, -3. And so this would get a bracket, and this would get 1 would get a parenthesis, and then everything shaded between them would be the graph. All right, let's look at another example. All right, in these two examples, we're asked to just solve and graph. So we're going to start by getting that x by itself by adding 19 to both sides. And that -19 and 19 will cancel out, giving us x by itself. Bring down your sign. 19 take away 7 gives you 12. All right, so on the graph, here's 0, 12, say is way down here. Less than or equal to, so we're going to put a bracket and shade everything to the left, because left would be less than. If x is on the left, whichever way it points, so it's pointing left, so we shade left. All right, let's look at the next one. Here I need to add 1/8, add 1/8, and subtract 4x from both sides. So that will cancel out that, cancel out that. And 5x minus 4x gives me x. Bring down my sign. 3/8 plus 1/8 is 4/8. 4/8 are both even numbers, so we can simplify that to 1/2. And so to graph that, here's 0, here's 1, 1/2 would be in the middle of it, and we would put a bracket there and shade left. Oops, I'm a little wide. And so that's where 1/2 would be. All right, let's look at another example. All right, so this one has some parentheses, so we need to apply the distributive property. If you don't remember the distributive property, anything in front of a parenthesis must be distributed to everything inside that parenthesis. So that's a times b plus a times c. Okay, so now we have, I'm going to bring my 22 down, distribute that negative, that'll be negative 3x minus 4 when we distribute that to both those terms. Distribute that 2, so that's 2x plus 6. Nothing happens with this x, so we're just going to bring it down. I'm going to combine like terms, so I have a negative 3x. 22 minus 4 gives you 18. Bring down your sign. 2x plus x gives you 3x. And plus 6. All right, I need to move my x's to my left, so I'm going to subtract 3x from both sides. And I'm going to subtract 18 to move the numbers to the right side. So that gives me negative 6x after the 18s cancel out. The x's here cancel out, and 6 minus 18 would give me a negative 12. Now I need to divide by both sides by negative 6 to get that x by itself. And that gives me x, and negative 12 minus 6 gives me 2. And since right here, this was a negative number, if you remember what I put on the first screen, we would flip the inequality sign because we multiplied by a negative number. So we must flip the inequality sign. All right, so this gave us greater than or equal to 2. Now you can always check this. If I say 10 is greater than 2, if I plug in 10, that's 30 plus 4, so 34. 22 minus 34, that's a negative number. 10 plus 3 is 13. 26 plus 10 is 36. So a negative number is less than a positive number? Yes, that's correct. Now, I like to show if I was on this step here. A lot of students forget the rule about multiplying or dividing by a negative number. So if you don't ever want to have to do that, you just got to make sure you never get a negative coefficient for your x's. So I can add 3x here, add 3x here, and this is going to move my x's to the right side. So now I'm going to subtract 6, and now I have 12 is less than or equal to 6x. Divide by 6, divide by 6, and now I have 2 is less than or equal to x. Now, these don't look the same because the x is on the left side and right side, but as you see, this opening is here, so if I rewrote it, in elementary school, we say the alligator eats the bigger side, so the alligator's eating the x. So make sure when you rewrite, the alligator's eating the x. And you can see here that these two are the same. Because I didn't multiply or divide by a negative number, but I still, when I had to flip the x to the left or right side, that's when I changed my inequality sign. So if you multiply or divide by a negative number, what I showed here, you've got to flip that inequality sign. All right, let's look at another example. All right, so now we have some distributive property again, and with fractions. So half of 6y would be 3y, half of 2 would be 1, minus 15, less than negative 1/3 of 6. Negative times positive would be negative. 1/3 of 6 would be 2y. Negative times negative is positive. 1/3 of 3 is 1. So we had fractions, but after we multiplied, no more fractions. Combine like terms, and we get 3y minus 14. Bring down your sign. Negative 2y plus 1. All right, add 14, add 14. Add 2y to move them left. And now 14s cancel each other out, and we get 5y is less than 1 plus 14 is 15. Divide both sides by 5 to get the y by itself. and we have y is less than 3. Pick a number less than 3 if you want to check your work. I would choose 0. Plug 0 in. We get half of 2 is 1. 1 minus 15 is negative 14. Plug 0 in here. You get negative 1/3 times negative 3, so that's 1. A negative number is a less than a positive number. That works out. All right, let's look at another example. All right, we have distributive property again, so we're going to distribute. 9/10 times 3 would give me 27/10. Remember, for multiplying um, a over b times c over d for all fractions is a times c over b times d. So that's 9 times 3 is 27. 10 times the understood 3 over 1 gives me 10 on bottom. Plus 9 times 6 is 54x over 10. Plus 1 is greater than or equal to 16. All right, combine like terms, 54x over 10. And then we have this 27 over 10 plus 1. So that's going to be 27 over 10 plus 1 would become 10 over 10. So that would be 37 over 10. Okay, so plus 37 over 10. Bring down greater than or equal to 16. All right, now we need to get the x by itself. So I need to subtract 37 over 10 from both sides. Okay, so left side is going to be 54 over 10x. Bring down your sign. And this right side, we have 16 minus 37 over 10. So 16 can be written as 16 over 1. So that's 160 over 10 when I multiply top and bottom by 10, minus 37 over 10. 160 minus 37 gives us 123 over 10. So 123 over 10. All right. Now to get rid of this 54 over 10, I'm going to multiply top and bottom by the reciprocals. So multiply by 10 over 54. So this 10 would cancel that 10. That 54 cancels that 54. And we're left with x is greater than or equal to, this 10 cancels this 10. And now we have 123 over 54. 123 can be written as 41 times 3. So this is 41 times 3. And 54 happens to be 27 times 3. So we need to reduce this because it's 123 over 54. 123 over 54. 123 is 41 times 3, and 54 is 18 times 3. So when those 3's cancel out, we're left with x is greater than or equal to 41 over 18 after you take out that multiple of 3. All right, let's look at another example. All right, in this last example, we've got a lot of fractions. So in all the previous examples, I have worked through them using just leaving the fractions as is. I'm gonna work through this problem twice. I'm gonna leave the fractions as is, and then I'm gonna show you another method of multiplying by the LCD. Both are mathematically acceptable, and maybe you'll figure out which one works best for you. So let's go ahead and distribute. And this gives me 5/4 x minus 5/8 minus 5/3 is less than 4/3. Okay, we need to combine these two. So 5/8 minus 5/3, those both go into 24. So I need to multiply top and bottom by 3 and multiply top and bottom by 8. So that's 15 over 24 minus 40 over 24. And that would simplify to, don't forget about your negative sign. So that's 55 over 24. So now we have 5/4 x minus 55 over 24 is less than 4/3. Okay, so now we need to add this to both sides. Add 55 over 24. Add 55 over 24. And so on the left side, you'll just have the 5/4 x. But on the right side, we have 4/3 plus 55 over 24. So we'll need to multiply this by 8, and that would give us 32 over 24 plus 55 over 24. Both these are positive, so this is 87 over 24. So now we need to multiply by the reciprocal. So the reciprocal of 5/4 would be 4/5. So let's multiply by 4/5. Multiply by 4/5. 4 cancels 4, 5 cancels 5. 24 is 6 times 4. And I can cancel out those 4s. 87 is 3 times 29. And there's a 3 and 6, so 6 is 2 times 3, so I can cancel out those 3's. All I have left on top is this 29. All I have on bottom is 2 times 5, so this is x is less than 29 over 10. This method that I use right here is called prime factorization. And there's lots of videos about how to simplify fractions with multiplication using prime factorization. So I want to work out this problem a different way, where I eliminate the fractions and don't keep them. So let me go ahead and rewrite out this problem. X minus 1/2 minus 5/3 less than or equal to 4/3. Now first I want to get rid of all the parentheses, so I'm going to distribute first. And that gives me 5/4 x minus 5/8 minus 5/3 less than 4/3. Now I'm going to look at all these denominators, and I have 4, 8, and 2 3's. I need to find the LCD that they all go into. So 4 and 8, 4 goes into 8. So I just really need the LCD of 8 and 3's, and so that would be 24. So what I'm going to do is multiply the entire inequality by 24. So 24 divided by 4 is 6. 6 times 5 gives me 30x minus 24 divided by 8 is 3. So that would give me 15 minus 24 divided by 3 is 8. 8 times 5 is 40. Bring down your sign. 24 divided by 3 is 8. 8 times 4 is 32. Combine like terms, and now I have 30x minus 55 less than 32. Add 55, add 55, and now I have 30x is less than 87. Divide by 30, and I get, we remember 3 times 29 is 87, and 3 times 10. So if I pull a 3 out of top and bottom, I get 29 over 10. And so a lot of the students prefer this way by getting rid of those fractions. And of course, you end up with a fraction at the end, but the numbers are the same. You can see the 87 there, the 30. We didn't really have that over here, but the 15 and 40, we had the 55 before. But sometimes it is helpful to eliminate those denominators and you can just focus on the numbers. All right, that's all I have for you today. Happy studying.